Welcome to EDU World Space.
Okay, so we're doing chapter 34, problem 35 here. So this one talks about the cornea as a simple lens, and it says it behaves as a thin lens of approximate focal length of 1.8 centimeters. Even though this varies a bit, we can assume that the material it's made out of has an index of refraction of 1.38 here, and its front surface is convex with a radius of curvature of 5 millimeters. Okay, so for part A, it asks if this focal length is an air, what is the radius of curvature of the backside of the cornea? So we're going to use the lensmaker equation for this, where we know that 1 over f equals n minus 1 times 1 over r1 minus 1 over r2. Cool. So let's go ahead and just plug stuff in here. Or actually, let's simplify things first. So we have 1 over f times n minus 1 plus 1 over r2 equals 1 over r1. So now we can say 1 over r2 equals 1 over r1 minus 1 over f n minus 1. Or r2 equals 1 over r1 minus 1 over f times n minus 1 inverted. Cool. So let's plug in our numbers for that, and we should have 1 over 0.5, because that's half a centimeter, minus 1 over 1.8 times 1.38 minus 1. Cool. That should be everything now. So let's plug that in our calculator, and we should see this comes out to being 1.86 centimeters. And this is R2. Cool. So now part B asks the closest distance at which a typical person can focus on an object is about 24 centimeters. Where would the cornea focus the image of an 8 millimeter tall object at that point? Okay, so if we rearrange the thin lens equation, we should know that S prime is SF over S minus F. If we plug that in, we should see S being 24, focal length being 1.8. We should see this comes out to being 1.9 centimeters. Cool. So that means when we're looking at an 8 millimeter tall object at the near point, the image we see is about 1.9 centimeters away from our cornea. So that's where we'd focus it. And we want to know what is the height of the image, and if it's real or virtual, and erect or inverted. Cool. So that's part C. So for part C here, we can figure out what the magnification is, and we know that that's going to be negative S prime over S, and that equals Y prime over Y. We rearrange that, we see that Y prime, Y prime is the one we're trying to figure out, is equal to negative 1.9 centimeters over 24 centimeters times 8 millimeters. So that means these centimeters will cancel out. We'll be left with millimeters, and we should see this becomes negative 0.61, not centimeters, millimeters. And it's negative, so that means we know that the image is inverted. And we also know that the image is real because it has a positive image distance. So S prime being positive means we're at a real. So inverted and a real image.